Alright, I'm just getting started. This is stream number 20, and I'm working on my web server that I've been writing from scratch basically. And today I'm going to look into some fixes and improvements to the core class called HTTP server. And about 15 minutes before the stream started, I started to see some odd issues with my PC, and I'm wondering if the hard drive is dying or if some other kind of hardware problem because everything froze. And looking at the event viewer later, I saw that there were some disk bad, whatever you see, bad sector errors. And then I saw that it was also in the log from previous days. And I had noticed sometimes right after I start up my machine, maybe a few minutes later, after starting up, it pauses for a bit. I'm wondering if it's pausing right there. So I don't know if you see my stream suddenly go offline or if I don't start up on schedule next time, it might be hardware issues. Hopefully that doesn't happen. Anyway, let me give a little overview of the project in case you're just joining or you're just checking this out. Let me open Visual Studio Code and we'll start Visual Studio itself just to get started. I'm actually using a slightly different monitor setup, so I've got an ultra-wide monitor, and so I'm actually using 80% of it. There's a little section off here to the right that you can't see that I can't stream from because I'm trying to keep the stream at 1080p. Anyway, this is our overall project right now. And if I go into, let's see, the README. So this project being a development area for a web server. In the past streams, we developed components to parse URIs, Unicode text, message headers, and message being HTTP or SIP or email, that kind of thing. They're all similar. And we have system abstractions, which has lots of utility classes we're building off of, and then HTTP, which has both server and client parsing of requests and responses and that kind of thing. And then this one, network transport, is kind of gluing together our HTTP classes with the underlying OS calls and system abstractions. So it's sort of like an integration layer. And recently we made a standalone program to host everything called web server. It's really just this main program. It sets up that transport layer we just talked about, sets up a server, subscribes to some diagnostics from the server, that is, and then mobilizes the server. It tells it what port number to listen to. It uses the transport layer to talk to the network. It sets up SIG_int so that if you hit Control-C, it will just set this flag shutdown. And then until that flag is set, we just basically wait a quarter second and over again in a loop. All of the real work of the web server is done by worker threads that are started by this transport layer. And the server object, right now, it doesn't do much in terms of handling requests. Let's go find where that code is. Here it is. So when data is received by the web server for a connection, it checks to see if the request is valid, and no matter what the request is, if it's valid, we just generate 404 not found with little twitch spin on it. And then if the request wasn't valid, we'll return 400 bad request. That's essentially it right now. We'll be replacing these canned responses with something a bit more intelligent. Not this stream, but maybe in a week or two, when we kind of have a solid base to work on. So, back to the plan for tonight, what I was planning to do. I thought about this last stream, about writing code for our main program for our web server so that we use the Microsoft C runtime library functions that detect memory leaks. And let's see if I can show you this just right here. There's a whole slew of things you can read about if you use Microsoft's runtime library, which we happen to be using right now. And one thing I'm going to use is this leak detection check, because I'm not 100% confident that I don't have circular references in my code which can cause memory leaks. So we're going to basically inject this code into our main function and test it around by making some leaks intentionally and also illustrate how we can use, I think it's down here somewhere, they talk about setting a breakpoint on an allocation number. Here it is. So once you get a number here, this 75 for example, you can set the CRT break alloc to that number, and then when you run your code again, it'll actually automatically stop at a breakpoint when that allocation is made, which is kind of handy if you want to see where the leaked memory was allocated in the first place. So we're going to work on that. And next I want to basically cover a security hole in the server right now where the first line of a request can basically be infinitely long and the server will just kind of fill with memory reading it. We want to cut it off at a certain limit and reject the message, basically close the connection if the line gets too long. Also, I was reviewing HTTP's spec, and it talks about the connection header, which we currently don't look at, but we should, because it's used by the client to tell the server to close the connection after a response is sent, or keep it open for further requests. So we don't handle that yet. We'll need to handle that. And then another header we need to worry about is the host header. It needs to match the value in the target URI. So let me bring that spec up as an example. We need to have this handy anyway. RFC 7230. So here's an example request, right? Host is supposed to be, if not the first header, near the top, and this host name needs to match the target URI. This kind of target URI is a relative reference, so it assumes it's a GET request relative to this resource, or well, it doesn't describe it very well. It says that this resource is gotten by this request. Presumably the server has this address. So if it was sent, instead of a relative URI, if you send it with an absolute one, it has to match. And they probably have a better example further on to show that. Blah, 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 just searching. Yeah, they talk about it down here. I guess they don't have a really great example. What I'm looking for is an example of a message that should be rejected. Okay, they don't have a good example. Most web requests are in that form of relative reference, so we really just need to make sure that we find a host header and that the host matches the server's address. If it doesn't, you're supposed to reject the request. So we'll be working on that. And then I want to improve the efficiency of the parsing of requests. Right now, it'll repeat the parsing of the beginning of a message every time it tries to parse a message until the request is completely received. So for a big request, that could be very inefficient. I mean, if you imagine if it's a 1,000 byte request and you send it 1 byte at a time, the server is going to be parsing that message 1,000 times until it succeeds. We wanted to only parse the data that's new. So that should probably fill up the time. I'm planning to stream for about 2-3 hours. So this is a good chunk of work that should fit into that 3 hours. So let's get started. Let's first add some memory leak detection. So the MSDN page basically gives us the code that we need. It's this setting of a debug flag. I like to do this because this leak check df flag causes it, like it says, to do an automatic call to dump memory leaks at the exit point, which is what you want. You want it to check memory leaks as late as possible so that it doesn't give you false positives. In other words, it'll say, oh, you leaked something, but it only says that because you haven't freed it yet. Like if you do the memory leak check first and then you free something. So this is nice because it's automatic and it's pretty much the last thing that the program will do. So loading my project. That's actually where it got stuck earlier, so I was a little bit nervous. So it's only going to work for Windows, so we'll guard this inside an if-def win32. And basically paste the code that we saw from the MSDN page, only I'll make it conform to my style there. And then what we'll add just as a placeholder is what we'll want to add if we see a leak, which is this CRT debug break. And we'll illustrate how we would use that. So we'll put that in there and we'll comment it out and build that. I apologize for any background noise you might hear. Got people playing games in the background and all that. So we're going to run our web server like this and Control C to exit. Oh, that's right. We won't print anything at all unless we redirect the output, and we don't really need it to print it to the console. It's really for when we're running in the debugger. So what I did is I right-click there and set up project. So now when I hit go, it should run our server. And there it is. And then you can still hit Control C in that window. Was I in the right window there? There we go. So when you hit Control C, you'll actually get an exception thrown, Control C, and you can hit go. It's basically giving you the opportunity to debug out when you hit Control C. So if we had memory leaks, we would see them here now. Hi Ubi, how's it going? So let's put in a memory leak just to test this. So somewhere in, it doesn't really matter where, we'll just cause a leak. Auto test leak. All you really need to do is allocate some memory and do nothing with it, right? Now when we run and hit Control C and hit go, now we get the beautiful detected memory leaks, and it'll tell us it's allocation 1612, right? So we can put 1612 here and uncomment it. And now when we run, it'll actually hit the breakpoint automatically, and you can look at the call stack and see, oh look, that's the memory that leaked. I think that's awesome. So we'll comment that back out, take out our test leak. Now if I happen to make a bug causing a circular reference, we'll be able to detect it just when our web server is closed. You know, hit Control C, run, and we see no leaks. I should probably do that, but before shutting down the web server, I should try to throw something at it, so to speak. That would be, I just go into my web browser and do localhost 8080, because that's the port number we're using. And we can see from our console here that it got the request. It actually got 3 requests, one for the root resource and then 2 for the fave icon. That's the little icon for the web page. So we sent 404 for all of them, and then Firefox gave up, right? So we'll hit Control C and then go. And great, there are no leaks. So basic requests and connections are all handled without leaking any memory, which is great. Let me go check that in. Yeah, I'm nervous tonight because I think my computer might have some hard drive problems. I don't like hardware problems. Okay, we did that in web server. Okay, where did my Get GUI window go? It's off the screen somewhere. I think it's because I changed my monitor setup. So what I'm going to do is go into the config here. And we can just use Notepad because it's just a quick edit. Oh, maybe not. Ugh. Let's do it with VS Code. VS Code. File open. That was in web server, right? Config. So it's this remembering the geometry, so we'll clear that. Go back to Get GUI. It changed my monitor setup around, so now whenever I was running Get GUI, it was opening the server where I couldn't see it. So now it's reset back. All right. So add memory leak detection when running debug build on Windows. Yeah, it only works for the debug build. The MSDN pages talk about that too. Did I check the GitHub desktop app? Yeah, I did. I still have that running here. It's actually pretty cool. Oh. One thing it doesn't have is the ability to stage individual lines and chunks. Or hunks, they call it. Otherwise, I'd be using it now. It's really hard to show with an example unless I made a change, right? Okay, let's say I wanted to stage just these two lines. There's no option here to just stage those two lines, right? And not stage the rest. Oh, it does have a way to stage lines. Maybe you could tell me where it is. Click on the blue section. Okay. Ooh. So that's selecting which lines to actually stage? For some reason that wasn't obvious to me. Well, if that's true, then maybe I will use this thing. Oh, I do like that. I like that a lot, actually. Cool. Okay, well that was the one thing that was holding me back from using it instead of Git GUI. So maybe you've just converted me. Awesome. Yeah, I'm used to having like a right click on the lines or the hunk and right click, and I'm like, okay, it doesn't have that feature. Yeah, that's cool. All right, we'll use that. Skip Git GUI. Use that instead. Thank you. All right. Back to the notebook. We did that. So next, let's enforce a maximum line limit on the request line. So this is going to be work on the HTTP library. So let's go to the HTTP library's tests, and I probably have a similar test already for this. Like collapse everything. Parse invalid header line too long. So probably like that. And it's going to be invalid request line too long. Right? I think what we'll do is we'll just make this the URI, and we'll call it URI too long. We'll just make it 1,000 characters. Get rid of all this stuff, and we'll break this up like that. It doesn't really matter if it ends in a character turn line fee or not. We want to catch it in both cases. Yeah, this is going to be an invalid unrecoverable. So I expect this to fail right now because we don't have a check for this in the code. HTTP tests debug HTTP tests, and it fails. And let's tighten our lens. All right, so let's go fix the code. And it's in this place here, right? So we don't check at all the length. Also, we'll basically end up looping this first section forever if we never get a character turn line feed, which is really bad. So we probably want to do the check for the length before we do this find, or perhaps after. Perhaps in here. Let's see what I did for the header lines. So for the header lines, we had that kind of check. Right? So we did the one check here. Okay, we just did 2 checks. That's what we did. So we'll do the same kind of thing. So header line limit. Basically, if it defaults to 0, right? Oh no, it defaults to 1,000. So it's always going to have a size. So if raw request dot length it's greater than the limit. If you guys haven't seen that before, that's what happens when I mute the mic. And I thought I'd be muting the mic most often when my dog barks, but usually I'm muting the mic these days because people ask me questions in the background. Or they're saying good night and that kind of thing. So maybe I should give my dog a reprieve and take his little video out of the overlay. Okay, so if it's greater than, we need to mark it unrecoverable, and return the we're only returning the request so that they can see the validity. Okay, and this is going to change when we do the last part of tonight's stream, which will be to refactor, rework this to be more what did I call it? I'm bad with words late at night. More efficient by building the request iteratively, right? So when we do this, a lot of the code we're looking at now will change. So this is if we don't see the end of line. If we do see the end of the line, we kind of still want to do the check just to be what's the right word? Just to be strict. We should try to be strict about the line length. Because the transport layer could give us a very large string, like a megabyte long. And even though it doesn't exhaust our memory, and we could process a megabyte long request line, we would be lenient to do so. Let's not be lenient. So that would be here. If the request line end, or really, let's just be very clear here. We'll say the request line length equals the request line end, and then we can use that in both places so it reads a little bit better. Maybe some config for that. Yeah, I was going to get to that. Right now it's just variable set to a constant, but I don't know why when I mouse over that it says bool false. It's 1000 right now. I do plan to make that in a configuration file, and I wanted to use JSON for the encoding of that file. And that was on my list to do, is make a JSON reader-writer, but it kind of got lower in priority because I wanted to get some of these security issues out of the way. TOML? What's TOML? Is that another format? Or is it? Let's take a look. Tom's obvious minimal language. It kind of reminds me of the old Windows INI format, actually. Yeah, I like JSON because I can reuse it for web sockets later. But I like learning new things. Let me add that to my notebook. What do I want to say? Take a look at. Be looking at that later. Thank you very much. Okay, so that's. I'm hopeful that will fix the test that we just ran. All right, so I'm actually getting through this quicker than I thought. So we've done the first two ones. Let's check that in. Oh, I said it. Okay, sorry. I said I wouldn't use Git GUI anymore, and there's another good reason is Git GUI is trying to open the window off screen for each of my projects because it's trying to remember the geometry of the window, and that was before I swapped my monitors around. Anyway, I'll fix that problem, but I'll use our new best friend tool. Only problem I guess here is I have to be adding a local repository every time I add one. HTTP. All right. And this is going to take me a little bit getting used to. I can import from GitHub as well and drag and drop there. Cool. Right, so this means they're already staged. I just need to put a summary in here. You can see my ugly mug on the left there. Sorry about that. Let's see. Request line too long. Yes. Restrict HTTP request line length. Oh, did it not state? What is this? Did I make a mistake there? How do I amend? It's probably one of these buttons, right? Undo. I just want to amend the last one. Oh, I guess undo and then commit again. It's the same thing, right? So that's the equivalent of a reset, I'm guessing. Yeah, all right, cool. So I just need to now train myself not to just automatically type git GUI anymore. I should just leave the damn thing up, shouldn't I? Just minimize it. All right. So next on the list, we're going to handle the connection header. So this is a interesting one. Git add. What does -p do? I'm not familiar with that one. Git add -p. Patch. Oh, iteratively choose chunks. I'm familiar with I use that one. So P is like interactive only. It just runs you through each patch and asks you. Yeah. So that's interactive is kind of like that, only you have to drill down and pick the one you want to stage. So this one just asks you for each one, I guess. That's cool. All right, so we're gonna focus on the connection header. There's a special section for that. Connection header here. So it's one of these headers that uses a special syntax, which means a comma-separated list of options. And right now we're just going to be concerned with the special meaning of the close option, which talks about right here. And it has to do with what the server does with the connection after it sends the response. So if this client says close, the server will send the response and then close the connection right then and there. Otherwise, it defaults to, I think, being left open if it's HTTP 1.1, which is all we're supporting right now. There are other rules about if it's 1.0. I think it's talked about, yeah, here in this section for persistence. If it's 1.0, then you can look for a keep alive option and choose to honor it or not. And it depends if you're a proxy or not. It gets a little complicated. But we're just going to handle these two, basically. It either persists or it doesn't, based on if the option is present. All right. Let's make a test for that. I'm just looking for a test I can kind of copy. Let's copy the GET request one. Well, you might be like me. How would I know? You might be exactly like me. Maybe you don't have the luxurious beard. Maybe you don't have the patience to be there. You want to be there already. Patience is a virtue, right? Okay, so parse request. So are you saying you want to have the web server all up and running by now? Good at understanding. I don't know about that, but the later I stream, the less I'm good at understanding. Let's just say that. My mind gets tired. Okay, so we're going to call this... so we can see that the GET request is sort of the default behavior where it persists the connection. We'll make this one... I know, I'll co-locate this one with the normal GET request. And we'll just make them brothers. So one will be GET request not close afterwards. And we'll make the first one GET request keep open. For you, it's been all high-level programming languages and tools. You had no clue about those details. Well, details are the hardest thing to collect because there's so many of them. I tend to just wait until I run into them, and I try to put them in a notebook so I don't forget them, or at least remember where I can go to find them again. If you get too caught up in like trying to know all the details, then it can be pretty frustrating. So let's see. These two tests are going to be pretty much the same. Give me some room there. Only at the end, let's do a check to make sure. Oh, hold on. I can't use this one. This is just doing parse request. So this isn't the test I was thinking of. This is not the test we're looking for. I think it's what we want is this guy. Client request in one piece. And we'll make it client request in one piece and client keep open afterwards. Client request in one piece, close afterwards. Is that source code open source? It will. I keep saying this. I've been sort of procrastinating, but I want to. What do I want to do? Double check that I'm doing the right thing by picking. I was going to pick the MIT license and just put it up on GitHub, but I just wanted to. I'm just a little wary of opening stuff up. You know. I guess I'm just not used to it. So, but yeah, that's the goal, is that I'll at some point just say enough's enough, deal with it, and put the license file in there and put it up on GitHub, and then pray that nobody laughs at me about how bad my code is. Okay, so yeah, they are really helpful, and I owe them a lot, right? So I should feel like I should be paying them back by giving my code. So yeah, I just need to keep telling myself that. You know what I think it is? I've been working at a company for 20 something years, and it's all proprietary, and they don't let me put code up on GitHub. And so I guess I've just been trained, it's been drilled into me to keep things private. I guess the first step towards breaking myself of that is I'm streaming, right? So people can see my code, at least little windows of my code now. Yeah. I just need to get over it and put it up on GitHub. So yeah, that's a good point. So if you had it in front of you, you wouldn't be like forced to look at the little window that I'm looking at. Like if I do this, you can't see my code. Sorry. Yeah. I'll put serious thought into putting it up on GitHub before the next stream, which will be Friday. All right. So we're gonna make these tests do basically the same thing, only. Actually, you know what? Let's leave this one alone, because this one does a lot of asserts that we really don't need to repeat. I'll just take that and kind of build off of it a new test. Yeah, just add it and push it now. I have to meditate on it a little bit in order to be comfortable with it. I promise to do that before Friday. I swear. Oh, everybody be nice. My mod Rally Monkey just joined us. I think I'll be okay with it. It's just like I said before. I'm just so used to saying people saying this is proprietary code. You must not let anyone see it. I just need to keep reminding myself that this is my stuff. It's giving back to the community. Okay. This is we're going to call this one connection close or not. I think what I want to do, right, mobilize the server. We don't care about the diagnostics. We'll put this in a loop. That's what we'll do. And we don't need the diagnostics. We don't need to check the data receipt delegate. The request we could put outside, right? Oh, wait a minute, no. Because we're going to want to put the connection header in here or not. We'll just make the connection header variable. Connection close or not? Could you put a string there instead of that camel case text? No, but well, it's got to fit this macro, which wants a test name. I could maybe put underscores around it. That's probably the closest I could get. Is that? I guess I'm used to reading camel case. Don't do that. Did I read it? Do you mean like? I'm confused. Change the macro. It's Google's macro though. Don't use underscore. And look and see what the macro does. It's probably a macro within a macro, and the test name probably ends up being some function in the class, right? It's like macro hell. I think it's going to be inside this class name. You see, it glues together those tokens to form the name of a class. So I got to obey the C++ rules for what I can name something. So you think that it's worse to have underscores than to just go back to camel case? Alternatively, I could just do this. Then maybe the C gods will be happier. Just use camel case, okay. Fair enough. Underscore is probably harder to see on stream anyway. Let's see. So we're going to put this in a loop. And we don't need that assert. And we don't really care what the response is. Could give a crap what the response is. What we really want to see is did the connection get closed right away or not? Classes, yeah. So I guess Google Test implements this in terms of a class. I try not to peek in there too much because macros are evil. Don't gaze at evil too long, right? Okay, so how do I want to phrase this? I really want to try with it on and with it off. So I've never looped a Boolean before. I really can't loop a Boolean, so I know what I'll do. I'll say for, I don't know, it can just be int. It's probably a better way to do this. Include close header. Oh, really? Do I want to say this? And then we'll say, just to make it a little bit easier to read, well, really connection header. Well, really, it's specify. Tell server to close after response. Connection header. Connection close or nothing. And then we'll say if we tell the server to close. The server is going to close its end, so it'll tell the mock transport. I need to make sure we detect that. Oh, right, mock transport makes one of these mock connections. Mock connection has a broken, right? So we can look at broken. Yeah. It's been a few days. I forget how my mocks work. Assert true, connection broken. I think this is easier to read. If we tell the server to close out the response, assert true that it's broken. Otherwise, assert false that it's broken. And because we're in a loop, I'm going to print the value of I for these asserts so that we should be able to see which fails. Oh, and another thing we can do, we could turn this into an expect. What that does is it'll continue the test, so we can actually test both true and false for tell server to close. Even if one fails, it'll still run the other. Let's see what that does. This is a new test. Connection close or not. Alright, so it's only in the, well, what we really want to know is this. It's the first case though where we want it to close. So it wasn't broken when it should have. And this true, we can pretty it up. Or did we ask the server to close? We asked the server to close? Yeah. This is just an example of what you can do to pretty up your unit tests. Because now when we print it, it says, we asked the server to close? True. So that's the case that broke. So it already works in when we don't ask it, so that's what we expect, right? It's when this header is present, the server should close it. So hopefully the code is not that complicated. We just get back to where the response is sent. Here it is. So after we send the data, we already break the connection if it's an unrecoverable. So what we can do is we can do two different cases. I could make this one monster if, but I like it this way better. If it is valid, if request headers has I guess we could do get header multi-value, and if there is no header, it just gives us an empty set, right? An empty vector connection. That can't be an if. Let's make it connection tokens. What's a vector in C++? It's a container that matches pretty closely what you'd expect for an array, where each element is adjacent to each other. Two adjacent elements have adjacent. Let me start over. I'm not explaining this very well. A vector, like say of n elements, will have elements 0, 1, 2, 3, up to n minus 1, all adjacent in memory. So you can convert it to a C array just by getting what they call the data member of the vector, or the address of index 0 of the vector. But it's got other methods like adding to the front, adding to the back, inserting into the middle. It does sorting. It does You know, a lot of the basic things you do with an array. Yep, basically. So this is going to end up being a vector. What we want to do is it's not a set or a map, so it's not searchable. Actually, is it? Let's see if there is a find. I can't remember. There's no find, but so we'll just have to do loop through it. Const auto connection. Inserting an update, then they're not the last item. Yeah, it's not efficient to insert in the middle, but it is efficient to insert at the end because it usually allocates memory in powers of 2. So if you allocate 10 elements, it actually allocates space for 16 and then basically has a reserve. There's an awful lot of yelling upstairs. Sorry about that. Okay, so it's if connection token. Can you guys hear the yelling upstairs? If it's close, we don't want to break it more than once, so we will have a boolean close requested. So it's just the reality of having a family. At bedtime, sometimes people are excited and sometimes they're yelling. If close request. We love so much C++ classes in school because of all the pointers and so on. I'm trying to come up with a good retort to that. I would say in modern C++, you shouldn't have pointers. It's C that has the pointers, right? Second year is PHP, and goodbye having fun. Really? PHP's not fun? Isn't it just a different kind of fun? Borland C++ builders. Ooh, that's pretty old, isn't it? Borland C++. Okay, since we're only looking for close, we could pretty much break out of this thing. Where I could just break it and not bother with this flag, but I kind of want to be able to refactor this in a bit. Anyway, so we're going to break. We had this argument, right? Clean? Yeah, we want to break clean. I need to make sure that that actually works on the real network. That clean argument is supposed to wait until all of the bytes being ready, bytes not yet ready to send are actually ready and then sent and then close. I don't know if our code actually does that though. Because close, it's supposed to only close after the last request is returned. Okay, so now it's passing. So let's check that in. Oh, hit me on the head again. I'm still using Git GUI. No more Git GUI, right? We're using GitHub Desktop now. Summary. This is the server. Let's see, obey or accept close connection request, close connection tokens. If close is included in the connection. You know, I wish this would tell me how many characters I've typed because I want to keep it to 80. I don't suppose there's a way to do that with this tool, is there? If close is included in the connection header tokens, close the request, or close the connection after sending the response. I'm just wondering, does it, Does it actually wrap at 80 characters, or do I really care? I guess I don't really care. Type more in the summary. Clickety clack. So you're saying if I did it in the summary, it's going to warn me when I get to 80? It's not warning me. Maybe it warns me when I hit commit. I'll have to play with this later. I'm not too worried about it now. Actually, what does it say when I do get log -1? So yeah, this is what I wanted to avoid. It didn't wrap it at 80 characters, did it? In fact, this is wider than 80. I'm trying to make it exactly 80. I wanted to wrap it right at the end connection. Or really before connection, so okay, so if I make it about that wide, that's a good indicator. So I can just hit enter, and that's close enough, right? Yeah, I think that's what I'll do. I'll just keep it about that wide. Preferences. I don't want to spend too much time looking into it, but we can. Options. It's actually pretty basic, isn't it? Yeah. Toggle developer tools. I know what that is. User guide. RTFM. Read the effing manual. Is that what I should do? Maybe we'll do that later. Do it off stream. It's an Electron app. Yeah, simple to use. There's always a balance or a trade-off, right? If you make something easy to use, the developers and the nerds get uncomfortable with it because it's not as much power. It's not as powerful, right? Make it too powerful, then it's not easy to use anymore. Yeah, that's what I expect it to do. Just like any Electron app, right? It should open up the browser, debug stuff. I wonder what it looks like here. Yep, it's like Chrome. In fact, it is Chrome. Source tree. I use source tree on the Mac. I haven't really given it that much of a chance on Windows. This isn't as wide as it could be. There we go. Alright, so next thing on the list. Requiring the host header. So this is a two-parter. The host header has to be there, and its value has to match our server's address. Oh, you use source tree all the time? Okay. It's a pretty good tool. I like Atlassian and stuff. So close connection or not, we did. So this one we'll call host missing. Oh yeah, there's one built into Visual Studio. I know they added that recently, right? I'm not seeing it. Oh, down here, right? One problem I have with it is, I guess it's the same problem I had with source tree and maybe with GitHub too. It can't auto-detect the repositories I have, which is something that Android Studio has that I really like. I wish other tools had. I wish I could tell it scan my workspace for Git repositories and just show them all to me. This one I have to add. Why should I have to tell it where it is? Can't it find out where it is? Like, well, let's give it a chance, right? When I do this, it should just say, "Oh, I found a bunch of them." No new repositories. It's like, oh well. Then I kind of lose interest in it. Source tree does that? I thought it does it? Maybe I'll have to look at that again. I thought even on source tree I had to like manually add them. But I thought GitHub desktop didn't have stage lines, and I was wrong about that. You need to rescan. Rescanning is fair. That's a fair request. Okay, so here we can basically just get rid of the host. And we should... Okay, not that it's going to be broken. We're going to expect a 400 response. I think here, rather than hard coding this expected response, I'm going to leverage our client class. We're going to give it a little bit of the brains of our web client class to parse the response. Is there a multi-line string in C++? Like you don't need to be open and close double quotes? I don't think so. Some languages have triple quote, but you can see Visual Studio doesn't like it. Yeah, not that I know of. I guess C++ isn't a cool language keeping up with the times, right? I don't know, maybe C++ 20 has something added to it. I know they added stuff to where you can have like symbols in front like that, and you can have it be interpreted differently. So we're going to leverage this client. What do we call it though? Just client? And we'll say client dot parse response the connection data received, right? Is it a string? Yes, so we'll give it all the data we received. And right now it returns a shared pointer to a response. So const auto response equals. So let's assert that we have one. And then we'll assert that we get a 400, because I don't really care about anything else other than that it should be rejected as a bad request, right? Is that what the spec says? Under host, it says something. I like to make sure I do what the spec says, if they're clear about it. A server must respond with 400 to any one that lacks a host header. Well, that's pretty straightforward, right? Or if it has multiple values, or one with an invalid value. All right, pretty straightforward. So status, that's what we want. So of course that's going to fail, and it should fail on 818 and tell us what the status code would probably, let's say 404, right? This one is called host missing. Yep. So let's go fix it. There are two parts of this. It needs to have a host field, and it has to have a correct value. Let's do the first one first. I think what we'll do is we'll do it in try request assembly. Parse request. Yeah, we'll do it in parse request. So we check everything here, so it won't. Actually, we can do it before we do the body, right? So we can even do it before the content length header. Check for host header, and all that we will do right now is check for it. So if, what is it? Request arrow headers. If it has a header host, then we're good, but it doesn't if we are going to return 400. So if it doesn't have one, then it's like this one. it's recoverable, meaning you can continue to use the connection, but that request will be a bad request. Okay. So we'll say server enforce requirement that request include host header. I'm liking this more and more than Git GUI. Second part of it, it's going to require a little bit of configuration, right? Because the spec says it has to be valid, and the validity, I think they say it up here, it has to match the, where does it say it? The client must send a value to the host that is identical to the authority component. And the authority component, if it's a relative reference, then it's relative to the server's host name, right? So if the URI is absolute or has an authority, it has to match. If it's relative, then the host has to match what the server thinks of itself as serving. That means the server has to be configured for that. Let's do the absolute one first. So if it has a host, and we'll make a test for this. Host not matching target URI. So here we'll say we'll have one of the absolute form, which is, what is it? Do we include the HTTP? I guess we do, right? Well, really, we're really supposed to use example.com because that's the special domain no one can register, right? But we'll say bad.example.com. No. It's going to the good server, but the host will be bad. Right? So there it should give us this also a bad request. And we will fail. So if it has a host, if the request target, what do we have available here? If it's a relative reference, it's one thing, which we are not handling yet. But if it isn't relative, it means it's absolute. Hold on. It can be absolute and still not have a target authority. So did I have that? It has fragment port query. I guess it's just get host, and if it returns empty string, then there is no host. So I guess we can just do that. Const target host request target get host. If target host.empty, if it's empty, then we use the server's own. Well, actually, in both cases, it has to match, right? So first, I know what I'll do. Basically, if it's empty, we'll fill it in with what we have in the configuration. Use server's host for target host. But we'll make that the subject of a test after we have the ability to tell the server what its host name is. For now, though, we'll get it if it is in the target URI. We'll get it from that, and we'll just make sure that it matches the host. Actually, no, it has to match the host and it has to match the servers. That has to match both the target and the server's host. So never mind. This is the target host check, right? I know what I'll do for now. I'll just say auto server host equals standard string get from configuration. If it's empty, target host equals server host. Right, so if request headers dot get, we can get it once. Const auto request host. Get header value host. What does it do if there are multiple values? Does it returns the as a composite? Yeah, with a comma separated, so it won't be valid if there's more than one host, which is what we want. So if request host is not equal to target host, then it's recoverable and we won't test the server host quite yet. We probably should. Check request or check target host. Check that target host matches server host. Just making a note so I don't forget to do that. So we're at least checking that the host is not missing and that it matches the target URI. And by the way, we should run that for all the HTTP tests, 'cause I want to see, oh yeah, so we have problems with some of our other tests. They're probably either missing host or the host is wrong, so let's look at them. So parse get request has the problem. We'll probably need to just fix that up, right? Okay, it had a host, but nothing in the target. Oh, I guess for now we'll just relax it. We'll just say that the server host equals the request host. That might solve a lot of our tests, and it solves them all. Yeah, so I think it's because most of our tests use a target host that's missing, a target URI that's missing the host field. So in that case, the actual host header is not matching the request unless we do that. Well, this does that, and then that does that to make them equal. All right, so let's check that in. Oh, almost did get GUI there. So server, check that host header value matches target URI. Okay. Now I gotta decide, do I want to go improve this efficiency or do I really want to complete this one? In order to complete that one, we gotta tell the server its host name. Yeah, maybe we should do that. So, is that a test for that? We need to be able to, we'll have a default host name of, I don't know, maybe just empty string. So that it can't accept any, well, it won't accept anything. Maybe that's what we want. Maybe if the host isn't set, it'll just accept any kind of request. But if you set it, then it will be restricted and only accept requests that match. Host, not matching. Server URI. And I guess that what we'll do is we'll tell the server Oh, we have configuration items. Oh, great. I forgot I added that. Let's define a configuration item called host. And we'll make it example.com. And we'll make two of these guys. We'll make one where it matches and one where it doesn't. This one will match. So assert that it's not equal to 400. A lot of this is copied, so I think I'll put this into a loop with a little bit of a. I did this in the past. So you make a internal structure called test vector, and you put the things that you want different in each test. So the first thing will be the server host, and the second will be bad request expected, bad request status expected. And then you have a const vector of those guys. So one will be www.example.com, and that should be false. Then we'll have bad expects true. So then we could put the entire test within this. And we'll put test vector dot server. Well, it's not server host really, it's host header value. And then we will say, just to make it more readable, if it's expected, then assert that it's equal, else that's not equal. And actually, I'm going to change these into expects. Or no, that has to be an assert, because if it is null, we'll just crash if we continue. But these can be expects, so if they fail, then it just goes on to the next test case so that it can test all the test cases. Fail for test vector index. Just to make it a little bit prettier. Oh, it's not supposed to have passed. It shouldn't have passed. One of them should have failed. Oh, it passes. No, hold on. Oh, it failed for the wrong reason. Sorry. So, yeah, it was failing because that wasn't matching. So this should clear it up. There we go. So it failed for index 1. It fails for the bad example, which is what we expect, because this doesn't match the configuration item, and we're just not using that configuration item yet. We should probably also make a test that the default configuration is there. Default server URI. Let's make also, actually we can do two things in this test. We can we can assert, is it just get? Git configuration. What does that return when there is no such item, though? Oh, it's going to return empty string anyway. Well, I guess that's fine. So we'll just assert for now that it's empty string, and then if we change our design so that we give it a real default host, then we'll test it in that test. So what I want to do have sort of the same test vector, and I want to show that when the default is empty string, that it's accepting. So we don't need this bad status expected, and we don't need this struct anymore. We'll just put the raw strings in there like this. And it's just test vector. And then it's just that we expect it not to be 400. That should already pass because right now it's accepting all the time. And so indeed it's only failing when it doesn't match. So let's go fix that. So that was in, where is it? Mobilize, T-mobile, parse request. Here we go. So where we have the to-dos. Right, so to make both tests pass what we want, we can have it start with the, is it request host? Yeah. Hold on, let me think about this. Yeah, we'll have it start out that way, but we'll say, no, the other way around. Server host, we'll get it from the configuration. Is it impl? Configuration host. But if server host is empty, we'll use the host in the actual request. Now the final check. Basically the same kind of check. Doesn't matter which one we change, so we'll change that the request has to match the target and the server. And I guess I don't mind combining those two. Like that. Alright, I didn't expect it to fail, so it failed here for index 1, which is the bad example. Oh, because we're not supposed to set it here. And why did I set it in the loop down here anyway? That we should only need to set this once. Okay, that's better. There we go. Oh. I'm looking for my GitHub desktop, but I quit it by accident, so that's that, and that's that. So we added server summary. Ensure request target URI matches server host. this this check is relaxed if the server host isn't set. The server host is set through the host configuration item. All right. I think that's about it for the host thing. So we have 4 down, 1 to go on original plan. Probably have extra time, so be able to get to something different that I didn't plan for, which will be fun. Okay, so improve efficiency of request parsing by building a request iteratively. So we're not going to need to change any of our tests. This is pretty much refactoring, I think. The idea is that in the server class, in parse request, rather than just naively parsing, oh, this is the wrong function. This is always parsing the same raw request over and over again. Instead of doing that, I think what we would want to do is only pass in what's newly received in the raw request, and instead we'll have sort of a current state. So let's introduce that first, the current state. It's going to be internal, so I'm looking for, yeah, here we go. So types. This type is used to track how much of the next request, actually it doesn't belong in the server either, it belongs in the connection, doesn't it? In the connection state. This type is used to track how much of the next request has been parsed so far, right? We'll still put stuff in the reassembly buffer, but we'll be kind of emptying as we go. So this is enum class request parsing state. And we'll say, first will be request line. Actually, I'll just make it camel case. And then the second stage is headers. And then the third stage would be body, right? In this state, we're still waiting to receive the full request line. In this state, where we've received and parsed the request line, but haven't yet received all of the header lines. And possibly some header lines. But received all of the header lines, right? In this state, we've received and parsed request line and headers, and possibly some of the body, but haven't yet received all of the body. Okay, now we'll need to have a state for that. Initialize it to a request line. And we'll say this is how much, or this indicates how much of the next request has been parsed so far. So which also means we'll need to have the request object that we're assembling next request. I was just thinking of two different things. Do I want to initialize it, and what should I say is the meaning of it? This is the state of the next request while it's still being received and parsed. And I suppose we want to initialize it. because why not? We'll just have to remember to make a new one after each request is fully assembled, and we want to make, prepared to receive the next request, right? So this try request assembly will be a little bit different. I think what we want to do is just pass the full connection state back to the server, rather than passing just the reassembly buffer. But let me see where this try request assembly is called, actually. It's called from, what is this? The data received delegate from the transport layer, right? Oh no, this is for a single connection. Okay, so maybe maybe we don't need this try request assembly. Or really doesn't it doesn't need to be a method of the connection state. I think that's what we want. We want to turn this around basically and make it doesn't need a pointer to itself. It just needs a pointer to the connection state. Yeah. So we're gonna just relocate this guy. That. So we're gonna move this guy. So connection state returns to being just a simple structure, which I think I'm happier with. So it goes to this try assemble goes right above data received. Oh, parse request is an outer method. I think we want to move that to be an inner method anyway. And we'll make this. Let's do that step first and verify everything is not broken. Before I do my next step. So the first, this should be the first step, right? So the only thing broken now is parse request is not available. It's right now an external API. So we just need to make it an internal one. And do we need the message end? I suppose not, because what does this do? It just puts it into the reassembly buffer. Oh no, it doesn't. All right, it's reparsing everything over again. Okay, yeah, because we're parsing out of the reassembly buffer. Okay, so yeah, because we're adding to it. Got it. Which I guess is what we want to do. Okay, so I think I know what I want. This message end we still need, because we don't eat anything past the message end. And really it's not message end anymore. But I'll change that name in a minute. So yeah, we want the version that has the 2 arguments, but we want to basically push that into the implementation. Right, so I'm basically ordering it from the bottom up. So data received calls try request assembly, which calls parse request. And we're basically going to move the body from here. No, where is it? From here inside. So this basically just returns impl parse request raw request message end. And to shortcut things, we will do the same thing here. Although it would have still worked either way, right? So the only reason for those outers, by the way, is for unit testing, right? So this allows us to test the parsing of requests without having a transport layer at all, which some of our early tests are written that way. So we pushed it into the impl so we can get rid of all the impl arrows. There shouldn't be too many. A decent number. But otherwise that should not have really changed anything. So we'll test that. If it works, we'll push that as a change. Okay. Server refactoring. And basically, I actually don't want to stage those yet. So I'll do this nifty option where I can say I don't want those staged. Oh, did I not? Did I not make? I thought I gave storage for the request parsing state. Did I not? Did I not do that? Let me go back. I did. So how come that's not showing up here? Or is it I'm not seeing it? Oh, it is. Here it is. So we don't want that, and we don't want these. But we want that removed. And we want this added. Right? No, we don't want these added. Oh, this is going to be a little clumsy. Okay, so here I'm running into a case where the way they do staging of lines and hunks is not so convenient in GitHub for desktop. So I'm going to flip back to using Git GUI, unfortunately. Because I have two changes that are kind of intermingled. Oh, I'm going to have to fix that up. So again, because I changed monitors the other day, my Git cache on the geometry for the window is all messed up. So I delete the cache, and that should fix Git GUI, so I can see the window again. Okay, so what I really want is to stage everything, but then unstage this new type stuff. Unstage that, and then here's where it gets tricky because I do want some of these lines. But I don't want others. Unstage those lines. Unstage. Yeah, see, what it's doing is I want that to be part of that. Yeah, it's mixing these in a way I can't untangle. Oh well, I'm just gonna give up. So unstage everything, go back to GitHub for desktop, and we'll just type in the two things that we did. Introduce request parsing state. Not yet used. But then the main refactoring, I should probably list that first. The main refactoring that we did is move implementation of server parse request into implementation. Will that fit on one line? I guess so. Kind of getting close to the limit though. That didn't stage everything, did it? I missed a few lines. Missed a bunch of lines. Because it's not staging all of them. There we go. Oh, I guess it did fit. I was worried about it going over the 80 characters. All right, so we've moved parse. We moved. I am lost. Parse request. The outer parse request is now just forwarding it to the inner, because the inner is called from a couple different places. The outer, and it's also called from try reassembly, or try request assembly. So now here's where we're going to change it up a little bit. Yeah, so we want parse request not to make a new request like this, but use one that's given to it. I think that's what we'll do. So we'll make this be an argument. And then remove that. Why doesn't it like that? Oh, because that should be a shared pointer, not a make shared. This is the request to... This is the request being parsed. So we're basically going to change this from being a parse it in one shot to being a parse it incrementally. And let's update the documentation to reflect that. So this method is called one or more times to incrementally parse a raw HTTP request message. For the first call, pass in a newly constructed request object and the beginning of the raw HTTP request message. continue calling with the same request object and subsequent pieces of the raw HTTP request message until the request is fully parsed, as indicated by its, what do we call it? Request parsing state or something? Request parsing state. Transitioning to, we'll have to make a new state actually, complete. Or I guess we can fold in the, there was that verified flag, right? That validity flag. We can fold that into validity, actually. I kind of like that idea. Complete. Invalid recoverable or invalid unrecoverable. We won't return null pointer anymore. In fact, we're not going to return anything. Actually, we can go ahead and return this message end. That's what we can do. We'll say this is the return value. A count on the number of characters that were taken from the given input string is returned. Presumably, any characters past this point belong to another message or outside the scope of HTTP. Exactly. So that's what we return now. And technically the pointer isn't changed, but semantically the request pointed to is changed. So I'm going to go ahead and say that in and out. I'm going to change it from raw request to next raw request part. This is the next part of the raw message. Just going through everywhere. I could have done a search replace, but I didn't want to be too aggressive in it, so just did it manually. So yeah, the callers of parse requests are gonna need to change a little bit, right? Because we'll do this in increments. So we'll just say that the request, const auto request, standard make shared HTTP server request. And now message end is just returned. Right? It's no longer null. How come in that's not like the request? Oh, I forgot to get rid of message end. Yep, okay. It's not that it's null, it's that it's... Oh, that's interesting. How come I don't see? It should be... Oh, hold on. I was confused. So that when I was typing this comment, I said it's fully parsed in the request parsing state, but that's in the connection, not in the request object. Hi dear. Hi, hello, hi dear. How's it going? Yes, so I got confused. I am putting that in the connection state, not in the request parsing, the request object. So do I want to divide this up? I guess we could put what used to be in the what I was going to put in the connection state. I can put it into the request. So yeah, let's do that. So that's this type. We'll just move it. We'll move it to the request. Checking out what I'm up to. I don't know if you've been here before, but I'm working on writing my own web server, and gotten pretty far because it's like 20, what do you call it, episodes or streams in, about 50 hours in. So I made a bunch of low-level components, and now I'm working on the component of the server that's parsing HTTP requests. It's working, and I have a web server working, but I'm refactoring right now to make it more efficient. So, where's my request object? Is it up here somewhere? I don't remember. Oh, it was in our header. It's in our public header. That's where it is. Our public header is on server.hpp. And here it is. Yeah, so where validity is, we're replacing it essentially. We're replacing this validity with parsing state, I guess. Or state? How about we'll call it state? Yeah, state. I like state. Catching up to do? Well, feel free to ask questions. I don't want to have to make you watch or skim through the 50 hours. That's a lot. So I can give a quick summary if you want, or if you just have some questions, I wouldn't mind answering. Of the request has been constructed so far. Yeah, I like that. This, yeah, okay. Instead of saying parse, we'll say construct. We've constructed. Yeah, I'm liking this more and more. So we need to add some states here, right? We're folding together the validity states, essentially. Valid is really that it's complete. In this state, the request is fully constructed and has passed all validity checks. And then we'll fix these up a little bit. Yeah, I guess the names stay the same. In this state, the request is fully constructed. But fails one or more validity checks in such a way that it should not cause the connection from which it was constructed to be closed. That's essentially what it is. And then the other one's sort of similar to that. What made me choose to do this project in C++ over a more modern language like Go or Python? Couple reasons. So I would say the main reason is I have the most experience in C++, and so I'm more comfortable in it. Another reason would be I kind of want this to be pretty well portable, so perhaps even to an embedded target, which doesn't have like the full Python, what do you call it? Life support system, I guess is a good name. So I want to be able to compile it down to machine code, basically. I guess you can do that with Go and Python, right? So maybe my first reason is really the only valid one. I'm more comfortable in C++. In this state, the request is fully constructed fails in such a way that the connection from which it was constructed should be closed for either for security reasons or because it would be impossible or unlikely to receive a valid request afterwards. Request after this one. I like that. So we're gonna replace validity with state. We're gonna have to change a lot there because I think we use this in a lot of places. So we'll initialize it to the request line state. So in other words, it's still constructing the request line. Or should we? Yeah, because everything is initially blank, right? Yeah, well, I like that. That means it's still being, the request line is still being constructed. And then the user of the structure will fill things in and then set the state to valid or complete. And if we're parsing it from strings, we'll progress through each of these in stages. Yeah. Okay, so I can see we fail here. Yeah, we're gonna want to fix this becomes this. This is the server request state to print. Validity. Server request state. And let's just fix that one up since it's fresh in my mind. This goes here, 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 and here, and this becomes complete. You okay? Well, thanks for stopping by. Okay, we have 3 more states. I know one's body, one's headers, and others request line, but I need to double check to make sure I didn't miss any. Request, headers, body, complete. Yeah, so there's only 6 of them. I think I'll keep these mixed case, and then these ones are all uppercase to signify that it's fully constructed, and whereas these are states when it's not fully constructed. All right, so we're gonna break in a whole bunch of other places. I suppose we should fix our tests first, right? Because those are probably gonna be broken as well, and they are. So we can replace validity valid with state complete. I know that. And that cuts it down a bit. Validity unrecoverable is just state unrecoverable and invalid unrecoverable. 4 more, and then we're down to these ones. Unrecoverable. Alright, so looks like our unit test will compile. Time to fix up our code. Okay, we removed this one because it's moved, basically it's moved into this request object. And same kind of, let's see. This code is all going to change anyway, so maybe we won't bother fixing up anything inside of parse request. But what's outside parse request? Okay, I had something incomplete here. Oh yeah, it was state. If state equals, I think I want a helper for this. So if request state request complete. Basically, if the request isn't complete, I suppose I could make that a method of the request. So right now the old behavior is that if it's not complete, we kind of discard it, and then next time we're just trying to parse the whole thing all over again. And we're going to turn that into an iterative process, but at first I want to do a mini step towards that, get it to work, and then do the next step. So that's the mini step. We just need to make this isComplete method. And that's in request, right? So we need to declare it. And that's a method. Just declare it. This method, I always accidentally capitalize the H2, returns an indication of whether or not the request has been fully constructed, valid or not. Indication of whether or not the request has been fully constructed is returned. Alright, and then we're going to go near where a nearby method is defined. Here. What's this? This is the impulse, so I suppose that's as good as any. Server request is complete. So it's just going to be, it's one of three conditions. If the state is complete, or it's invalid recoverable or invalid unrecoverable. Why doesn't it like state? Didn't I call it state? Oh, did I not actually declare? Oh, it's still called validity. Ooh. That should be state. And that probably broke the unit test because it peeks into state, doesn't it? Yep. So request validity becomes request state. Oh, okay, good. That was just search to replace, fixed it, everything. Okay, good. So I know about parse request, needs to be fixed. This doesn't need an argument. Yeah, so this becomes state is state complete. Right. And the same thing again. And like that. Then down here, it's a little bit different, right? We have to make a new request each time. And then we pass in the request as the first argument, right? And the message end is returned. We can ignore it for this one, and we return the request, right? Well, hold on. I think that's correct for now. No, it's not correct. It's not correct for now. It's only returned if it's complete. So if request is complete, then return it. Or, well, better would be if it's not complete, then toss it. Right? And return either not return the request or not. And then I'm just gonna go back to that just to be simple, so I don't have to repeat this logic. So last but not least, we need to fix up this method. I know I said I was going to change this code around, but I'm going to hold off for just a little bit longer. I'm just going to fix up the name changes here. Just because I don't want to do so many changes between tests. Just want to get it back to a compiling state. Verify we didn't break anything, and then do the iterative changes here. Okay. Oh, yeah, I don't need to declare it twice. And what's this now? Oh. I think this is supposed to be impl. No, it's not. Oh yeah, this is still the old style, so it's... Yeah, okay, so back to where it was. And then auto request equals that. Hold on, this doesn't look right at all. Oh, sorry, that is message n. So, why did it get turned into a string though? No. No, this is messed up. So, what did I want? I wanted to turn this into something else, but I wasn't done yet. So let's turn it back. Let me make sure I understand how it's being called. Yeah, I completely screwed this up, didn't I? Well, let's fix the prototype. Okay, so I meant to turn this into size t and then return it. So let's just fix that part up first. So instead of returning the request, it's returning the message, and the request is passed in. But we'll just assume right at first that it's a new message. Yeah, so yeah, okay. I think this is all we need to do. I really don't like having the same return everywhere, though. I'm inclined to just get rid of the return value. Force it to be passed in. No. Well, that's okay. We'll leave it like this for now. I just wanted to compile now, so... Make a new request each time. Then this is the message end. Request, comma, reassembly buffer. That fixes it, right? Only this is redefined. Oh, yeah, it is. And then there was a plus somewhere. Oh, because of the other error. Unreferenced. Yeah, I remember seeing that. I did this wrong, so... That's okay, but this one isn't, because we actually want to get the real one. And we get it by setting message end equals, and this is a request, comma, raw request, and we have to make a new request each time. Yeah. Quest. Yes. Oh, but only if it's complete. Yes, okay, good. So what's the difference between these two? This should really call this one, right? That's a bit simpler. I think that's what I had originally, anyway. Okay, I want to make sure this didn't break anything. I'm really hoping it didn't. I have a suspicion I did break stuff. I did break stuff. Of course I broke stuff. Break stuff all the time. But then we go and we fix it, right? So, service test 223. Oh, yeah, well, our test is not valid anymore. So what we want to see... Actually, that should have returned... It should never be null anymore. Oh no, it still should be null. So the test is valid. Actually, I'm kind of wondering why that failed. Let's run through it. I probably have a logic inversion. And I don't have the right project set up to run. So let's change that. Set that up to run. And I'm probably limiting what tests. Project settings. Yep, so remove the filter.